Hi, in this video I want to show you the new function calling capabilities of OpenAI's models and also want to show you how you can integrate this new feature with LangChain. Function calling provides a new way to connect GPT's capabilities with external tools and APIs. I will show you how this works in detail. You can get the notebooks with the code in the description, and this notebook is part of my complete LangChain course, which I also provided here on YouTube. So I'm here at VS Code inside the Functions IPython notebook, and I will just walk you through the code. To make this work on your own computer, you need an API key for OpenAI, and you need to save it in a way like this, where you have got this .env file, and the key is OpenAI API key, and then you have to provide here your own API key. So first, to make this work, we have to install some packages. We have to install LangChain, python.env to load the environment file, and also OpenAI to make a connection to the OpenAI API. So after installing the packages, you have to make sure you use a current version of LangChain. You have to use at least the version 00200 because otherwise functions are not supported yet. As you can see, I've got 201, which works fine. You should have a similar version like this. Okay, then we load the API key and set the API key property of the OpenAI module to the environment variable's value. So now we can make a connection to OpenAI. And first, to make functions work, we have to define a function. We mock a little API call here, get pizza info, and you can pass in a parameter, which is a string. It's the name of a pizza, for example, Hawaii, salami, or whatever. And then you get back a fixed price, which is always $10.99 in this case. And then you just return the value as JSON, so as string, not as dictionary. So besides defining the function, you have to provide a description of the function. And in this example, we could have multiple functions. This is just a list. And here, every dictionary provides the information about this function. As you can see, this name parameter matches the function name provided here. Then you have to provide a description, which is important for the LLM, for the language model, to identify if the function is suited to answer the user's request. Inside the parameters dictionary, you have to provide multiple information. For example, like in the properties dictionary, we have to provide information about the pizza name, which is the argument name here, and we have to provide the type and also the description. Like I said, this is important for the LLM to get the information about what you can do with this function. And then we also have to set this pizza name argument to required because we don't have any default values here. So this is the information for the LLM to know what to do with the function. Okay, after providing this kind of information, we have to use it. And I defined a little helper function here called chat, which takes one argument called query. This will be a string, and this will be the request of the user. First, we have to define the API call, which we make by the chat completion class from OpenAI, and we call the create function here, and we have to provide the model. It's very important that you use the newest models here with all end with 0613. For example, GPT 3.5 Turbo 0613, and there's also an equivalent of GPT-4 with this kind of ending. Older versions do not support functions. Okay, then you have to provide messages, and this will be a dictionary here with the role, and the role is currently user, and we provide the content which will be passed inside this chat function here. And then as additional parameter here, you have to provide these functions argument. So, and by calling this, we will get a response, and the response is a more or less complex object, and we can get the actual message from the AI by calling the response. And then there's a dictionary called choices, and this is a list which we try to retrieve the first element, and this will be another dictionary, and we will retrieve the message. So there's a lot of stuff like the called tokens and so on, which we don't need to demonstrate this example. Okay, then we define a function. So okay, now we can ask the model, what is the capital of France? And if you run that, we get an answer. And as you can see, this will get us back an OpenAI object with content, and the answer is here, the capital of France is Paris, and the role is assistant. Assistant is always the role of the AI, and user is always the role of the user who makes the request. What's pretty nice about this is that the API already provides a JSON object, which makes it easier to convert this kind of information to a dictionary. Before it was just a string and you had to retrieve the information, for example, via an output parser. So if you used OpenAI before, I think in general, the output here should still look pretty familiar to you. So now what happens when we ask how much does pizza salami cost? This is clearly something related to pizza. And we provided the LML the information that it should use the getPizzaInfo function if the description here has to do something with pizza. And if you run this, now it should look different. So, and now the output looks quite different. As you can see, we don't have anything in the content. This is just null, but we have got this additional function call object, which is a dictionary and has got arguments and the pizza name and also the value of the pizza name. So this is the parameter for our function, and this is the value we want to pass to our function. And the name of the function we want to pass it to is the getPizzaInfo function. So this information we want to use now, and we can first check if actually we've got this function call object here, and if yes, we know that the LLM wants that we call the function, and we extract from this object here the function name like this. We have got this function call object, and then we want to retrieve the name. So this will be the function name we want to call, and we also want the pizza name salami, which will be the argument we want to pass to our function. And this is a little bit more complicated. We get the function call and the arguments, and then we've got this object here, and we convert this from a JSON object with JSON loads to a dictionary, and then we extract the key with pizza name, and then we get the value salami. And this is the name we want to pass to our function. And then we could make normally the API call and retrieve the information. And this is the function response. This is also a JSON object which we retrieve from this function here. And with this result, we want to make another call to the API. Again, we use the newest model here, and we also pass in the messages before. We also pass in here the message, which we get back from the response. And in addition to this, we pass in another object with a role called function, and we pass in the function name here, which we extracted here. So this function response is the pizza info with the name and the price. We pass it here, and then we make the second response. And if we print this, we get a complex object here, and we can find the content here. The cost of pizza salami is $10.99. So the function response will be used to create a human-like answer with the information from our API. So this is what function calling is all about, to let the LLM decide if you want to use additional information or external information, or just let the LLM itself answer the question. So this was the vanilla way to do it, and now we will take a look at how it works with LangChain. Currently it feels a little bit hacky, to be honest, but for example, agents have been implemented yesterday, and this works pretty nice, but normal chains don't work as I would normally expect. But I will show you how to make this workaround work. So first we import the chat OpenAI class and human message and AI message and also chat message class. These classes help us to create this kind of functionality with the role, user, and so on. And we only have to provide the content here. As you can see, we've got this human message, just provide the content. And here we create a model, the LLM, with instantiating chat OpenAI. And we also pass in the newest model here. Then we run the predict messages function, and we can provide an additional keyword argument here, which is called functions. And we will pass in our functions, which were defined above. And now we can see AI message and the content, the capital of France is Paris. So far, so standard. And now we run again the query, how much does pizza salami cost in the restaurant? Okay, and now we would expect that we don't get content back, which we don't, but we get back additional quarks here, and the additional quarks include this function call dictionary with a name, and the name is the pizza info. So we can see the LLM suggests that we should call our pizza info function first, and the arguments here are pizza name and salami. So this looks pretty similar to what we've done before without LangChain. So now if we take a look at the additional quarks from the first response here, they are empty. This is just an empty dictionary. And if we get a function call suggested, we can get it here with the additional quarks. Here we've got our function call, the name, and also the arguments. So we can now use this kind of functionality to define if we want to make an additional call or not. Okay, to get the pizza name, we do the same like before. We just extract the additional arguments here and convert this to a dictionary with JSON loads and get the pizza name by calling the get method from the dictionary. Then we get back the pizza name, which is salami, and we call it here again like this. And then again we call the function like this again, and we get back name salami, and the price is $10.99. So now we can use this API response and create our new API call with the predict messages function. And here we have just the human message, which we will provide our query, and the AI message, we will just provide a string of the additional keyword arguments here. And then instead of providing this function here, we will just use the chat messages class, provide the role function here. And then as additional quarks, we will provide the name, which will be the function name. And also as content, we will provide the response from our so-called or mocked API. So if you run this again, we should get the similar response like before. AI message, content, the pizza costs $10.99 in the restaurant. So pretty easy to use, but working with these kind of additional quarks still feels like some kind of hack to me. LangChain already provides another standardized way to work with the outside world to make requests or whatever. And these are called tools. Tools are classes provided by LangChain. You can also create your own tool, and I will show you how to do this. First, we have to import the base tool class, and you can create a custom class or custom tool by inheriting from base tool. And then you have to provide a name for your tool and also a description. This is a very simple and non-functional tool. Just to provide you a little bit of the syntax here, you have to define an underscore run function and an underscore a run function. This provides async support, and this is for synchronous support. So I actually return just here, it is funny because AI. So no real functionality. You could of course query databases here or whatever you want, but I will just show you what you can do with it. And if you've got your own tool with a class here, and you can easily convert your own class with the format tool to OpenAI function to an OpenAI function. I also imported here the move file tool, which allows you to move files on your computer. And I create a tool list here where I instantiate my own class and also the move file tool class. So I've got two tools here, and I will just iterate over the tools and call the format tool to OpenAI function on all of my classes. And now I don't have classes here, but I have functions. I will show you how they look like. Just print them here. And if we take a look at them, they've got a name like stupid joke tool. They've got a description. This is taken directly here from these class parameters. And here the properties are the underscore args. And we can provide a title here, which will be also underscore args. We can also see what arguments are required and what type they are of. So this looks exactly the same like in the function definition I provided above. So now again, we can use it like this. For example, why does chicken cross the road to get to the other side? Some kind of joke often the AI does. And now I can run the predict messages function, and we will provide the two functions here and let the LLM decide if they want to use a tool or not. So as we can see, we don't get any content back. So the AI wants us to make a function call, and the function call is our stupid joke tool class, or the function which we converted the class to. So now we don't actually have a function, we just convert the tool itself to a function definition, but not to a function itself. So we have to run still the class, and here in our tool list we have got the first tool. The first tool is our stupid joke tool, and we have to call the run method on the question here. And we get the question here with JSON loads. We extract from the additional key arguments the function call and then the arguments. And since this is called arg1 underscore arg1, we have to extract it like this, and then we get to the other side. So we pass this to our function, and then we get back our tool response, and our tool response is, it is funny because AI. So this is just a static response from our custom tool. And now we can use this tool response again to make an additional request. Again, the same pattern like before. We pass in a chat message here with a role called function, and the content is our tool response. So this might not even work as expected because, it doesn't work as expected because, our tool doesn't provide any functionality, but I think you see the pattern. Make an initial call, And if the LLM wants you to call a function, you call the function and provide the output of the function to another LLM call. So this is how it currently works with the normal LLM chain. To be honest, with agents, it's already implemented much better. I will show you how this works. And first we import some kind of chains, for example, the LLM math chain and also a normal chat model, here chat OpenAI, create our LLM, and we also create an LLM math chain, which will be used as tool for our agent. So this agent is able to answer normal questions and also do some calculations. So for example, we use it like this. We use the initialize agent function, and now we use it here with our tools, the LLM. And now we have got this new agent type, which is of kind OpenAI functions. So if you run this, we don't have to pass any kind of keyword arguments or additional quarks here. We just use it like this. So now we run, what is the capital of France? And we get back, the capital of France is Paris. And if we want to know what is 100 divided by 25, here the calculator gets invoked and we get our final answer. 100 divided by 25 is equal to 4. So with agents, it works pretty flawless, and I think it is only a matter of time until it works with normal LLM chains too. Okay, that's it. If you liked the video, feel free to subscribe to my channel and give the video a thumb up. Thank you very much. Bye bye.